So today I am going to discuss the mock test 28 to this week. How many we cover, we will see. So write the test number 28 and I am answering you whenever some, or if you have, you can take from here. You have the bunch of papers. You want to drink? You want to drink? Ready, all of you? So the first question. Species with isostructural. From this you can directly answer. Or shall I read this? Isostructural pairs. Find the bond pairs, clone pairs. Find the bond pairs, clone pairs. So go to the last option. In BrO3 minus, bond pairs are 3. 3 oxygens are there. Clone pairs 8 minus 6 by 2. Why 8 minus 6 by 2? Bromine valence electrons are 7. Minus charge means 1 electron you have to add. So total 8. 3 oxygens, 3 into 2. Oxygens are bivalent. So 8 minus 6 by 2, 1. So 3 bond pairs, 1 lone pair. 3 bond pair, 1 lone pair combination is always pyramidal. So in last option, first one is pyramidal. The second one, xenon trioxide. XeO3. Here also bond pairs are 3. Lone pairs are 8 minus 6 by 2. Because xenon has 8 valence electrons. So again this is also pyramidal. The second question, 52nd. Correct order of acidity. Now the first option, acetylene, CH triple bond CH. You write there, it is sigma SPS bond. Sigma SPS. So Sp carbon is more electronegative. Sp carbon is more electronegative. That's why the hydrogens of acetylene are acid, followed by propyl. Propane also contains SPS carbon, sigma SPS. The next one is ethylene. Last one is ethane. Because ethane sp3s. I will show this. Here is our engineer. Okay, let us wait, let him come and verify. So I will do the answer again. What the this stylus functions? 53rd question. Nickel carbonide is tetrahedral because the nickel is sp3 hybridized. So both are correct. In metal carbonides, you have how many metal carbonides? Nickel carbonide, iron carbonide, chromium carbonide. NiCO 4 times, FeCO 5 times, CrCO 6 times. Total you have 3 types of carbonides in our syllabus. In NiCO 4 times, tetrahedral sp3. FeCO 5 times, sp3d, trigonal bipyramidal. This I explained by comparing their bond pairs, lone pairs. This is 8 minus 6 by 2. That is equal to 1. Here also bond pairs are 3. Lone pairs are that is equal to 1. So this combination will give pyramidal shape. So both are pyramidal means it is isostructural. This is the first question. Now the second question I answered. 52nd. So CH triple bond CH. This is sp carbon and the bond is sigma sps. The sp carbon is more electronegative. More the electronegativity, more the acidic nature for hydrogen. Now this is greater than propine. Here also sp carbon, sigma sp s bond. Then why it is less? Why the first one is more? Because the plus I effect of methyl group. Plus I effect always decrease acidic strength. Then it is greater than ethylene, CH2 double bond CH, where the carbons are sp2, which is greater than sp3. So electronegativity of carbon decreases sp greater than sp2 greater than sp3. This is the electronegativity of carbon. Now 53rd. So the geometry of nickel carbonate. Repeatedly I am advising you all these structures of the different molecules. Write on A4 size paper. So that whenever structure based questions are there, you can easily answer. Nickel carbonate is sp3 hybridized and it is tetrahedral. Now if you go for iron carbonate, FeCO5 times. This is iron carbonate. sp3d hybridization, trigonal bipyramidal. This is another carbonate. We have one more carbonyl called chromium carbonate. This is chromium carbonate. Total 6 carbon monoxide. sp3d2 octahedral. So this is all related to 53rd question. 54th question. 54th question. Ethyl bromide plus KCl or NaCl, whatever it is. Ethyl cyanide plus NaBr. Here, the Br minus nucleophile is replaced by Cn minus. One negative ion replacing the other negative ion. Because this is nucleophilic substitution bimolecular because it is a primary alkyl halide. Primary alkyl halides undergo SN2. SN2 is favored by polar eprotic solvents. polar aprotic solvents like acetone, number 2, dimethyl formamide. This is abbreviated, we call it as DMF. Dimethyl formamide. Dimethyl sulfoxide. Dimethyl sulfoxide, DMSO. Fourth one, acetonitrile. Or acetonitrile. So in the question number 54, they are asking which solvent is better for this reaction. The answer is N-dimethyl formamide, DMF. Suppose if it is more than one correct option type, if all the 4 are given, all the 4 are correct answers. Next question, 55. Which of the following is incorrect for ideal solution? So in case of ideal solution, like let us say 25 ml of benzene you are taking. Another beaker, 25 ml of toluene. Benzene and toluene may form an ideal solution. In ideal solution, AA, BB. AA means benzene, BB means toluene. Their interaction should be equal. The magnitude of molecular interactions in solution of A type, that is benzene, between one benzene and another benzene, they have attractive or repulsive forces. They are called molecular interactions. So the magnitude of molecular interactions of the two different components must be equal in magnitude. That's why we mix them. Both are poured into another beaker. The resulting solution should be 50 ml. So the volume should not expand or contract. That's why what we say, delta V mixing is equal to G. Similarly, by mixing these two, neither heat is absorbed nor released. So delta H mixing is equal to 0. So whenever an ideal solution is formed, what should be 0? There should be no volume change. There should be no energy change. So delta H mixing is equal to 0. Delta V mixing, not U actually, it is V, correct it to V. Delta V mixing is equal to 0. Delta P, let us say this is PA, partial pressure of, this is PB. After mixing, P total is equal to PA plus PB. So there should be no pressure change also. Or here they have given P observed minus P calculated. Difference is 0. That is also correct. But delta G mixing is equal to 0, that is wrong. Delta G is free energy. So whenever two liquids are mixed, they are instantly mixed with each other. It is a spontaneous process. For all spontaneous processes, delta G is equal to negative. So what is the wrong option or incorrect? Delta G mixing is equal to 0 is incorrect. Now we are going to 56th question. Fifty-sixth question. So they have taken benzene plus N-propyl chloride. This is treated with aluminum chloride anhydrous. What is the meaning of anhydrous? Without water. Why without water? Why not with water? It is a good chemistry. Actually, aluminum has vacant orbitals here. Without water, the vacant orbitals are free. If water is there, water will donate electron pair. It should act as a Lewis acid. Anhydrous aluminum chloride always act as Lewis acid because it has vacant orbitals. That's why what it will do, it will take away the lone pair from Cl. Cl says, my dear AlCl, I want to detach from the carbon group. I want to come as Cl minus and donate an electron pair to you. Then it says, okay, you come. Then you will get a primary carbocation plus AlCl4 minus. So what you are getting? Primary carbocation. You know, primary carbocation is unstable. Primary carbocation, it is less stable. Carbocations always undergo rearrangement. Rearrangement by how many ways? We many times discussed 3 ways. Either by hydride shift, or alkyl shift, methyl shift, or by ring expansion. Here ring is not there. One hydrogen will shift along with its bond pair. H minus will shift here. It is called 1,2 hydride shift. Because of this hydride shift, we are going to get plus charge here. We are going to get a secondary carbocation. Secondary carbocation. Now the secondary carbocation are more stable. Why secondary is more stable than primary? Due to 2 factors. 2 plus groups are there. or more number of hyperconjugative structures. What is hyperconjugation? Sigma P overlap. Doctors are very precise. The precision you should learn. Last week at this time I am in a hospital for a big surgery. It is a 4-hour surgery. It is called a robotic surgery. It is also called a Da Vinci model surgery. The surgeon is very efficient. So surgery, anesthetist, physician, a well coordinated effort. So robotic surgeries are slow actually. So robot in a 3-dimensional view it observes. Surgeon only observes. Surgeon is just pressing the buttons of the keyboard of the computer. So robot is cutting and doing the remaining things. So immediately after 1 hour I am awake. Next day they ask me to go out. See, why I am telling this? See, that much precision. The medicine, studying of medicine, applying on the human beings, is a very precise things. Anything goes wrong, so that is the end of the life. So carbocation stability is explained by plus I effect, hyperconjugation. What is hyperconjugation? Sigma P overlap. All these continuously should work in your brain. So actually you are all, one thing is good. Whenever there is free time, you are all dancing, running, jumping, loudly shouting. These are all good things only, not bad. That will rejuvenate your energy. Energetically it is favorable. But that energy must be converted into studies also. So the days are coming fast, okay? Okay, now the secondary carbocation attacks the benzene ring. CH plus. This is isopropyl carbocation. So this will link here, and this carbon will get plus charge. This is called erinium ion, which is also called R sigma complex. Sigma complex. It is called cumene hydroperoxide. So this will undergo a cleavage on heating, giving phenol plus acetone. This is all phenol preparation actually. But all these steps are important. Here you are getting carbocation rearrangement. Now this is called EAS, electrophilic aromatic substitution. This is electrophile. Any positive species is called electrophile. Electrophilic aromatic substitution. Now coming back to the next one. Uh, 57 direct E is equal to hc by lambda. E is equal to h nu. We know nu is equal to c by lambda. So E is equal to hc by lambda. If you apply this formula, you will get the answer. Next question. The major product C and D. The major product C and D in the following reaction. So N-propyl tertiary butyl ether. So this is the ether. CH2, CH2, O, CCH3 thrice. This is the ether. Now this is treated with HI excess. See the question properly. Excess of HI and heat. So whenever the ethers are heated with HI, the first step is ethereal oxygen gets protonated. Ethereal oxygen gets protonated. So what you will get is CH3, CH2, CH2OH. CH3 thrice and O become positive because it donated an electron pair. This is called oxonium salt or oxonium ion. Now this oxonium ion the I minus is weighting. It will attack more stable carbocation. This bond will shift towards O. So I minus attacks more stable carbocation. This is a tertiary carbocation. So the final product is CH3, CH2, CH2, OH plus CH3 thrice I. But HI is excess. That's why one more HI molecule reacts. Here the H plus, I minus, one more protonation occurs. So again the reaction, same mechanism continues. This becomes OH2 plus. So I minus will attack here, water will be losing. So this is one product, this is another product. If excess is not mentioned, these are the two products. Here if excess is not there, reaction stops here. One is alcohol, one is alkyl iodide. So that you have to be very careful while going through the question. So reading the question is very important. Very, very important. Reading 4 options also very important. Because students do small mistakes. That creates a big problem. That's why recently Gukesh, I think you heard about Gukesh, a person from Chennai. His father is also a doctor. So he played world chess champion, that challenge league, and he became the world champion like Vishwanath Raman. So whenever you see world championship or any international chess matches, the player first note down what he is going to move on a paper, and he will stand up and see the board from other side. He will move from his place. He will go to that place. He will go to behind the opponent, see from that side also. Because though we think this move is correct, maybe unknowingly some other dangers are there. So he will watch all around. So that much concentration. Concentration only that plays a big role. So now onwards, whenever you are attempting questions, read the question properly, read all the 4 options properly. So that you can avoid 10 silly mistakes. 10 into 4 marks, your score will be increased by 40 marks. Real. Next question is over. Correct increasing order for the wavelengths of absorption of visible region in the complexes of chromium 3+. Strength of ligand, the question depends on strength of ligand means spectrochemical series. We already discussed in the coordination compounds. See your notes. So strength of ligand, ethylene diamine, En is greater than, ammonia is greater than water. This is strong ligand. This is weak ligand. Weak ligand means we are asking the question absorbing the light. It requires less energetic light. Less energetic light means nu is less. Nu is less means lambda is more. So your answer is more. First option. 60 question number. Now question number 60. X and Y combine to form 2 compound XY2 and X2, X3, Y2. 0.1 mole of XY2 weighs 0.1 mole. XY2 weighs 10 grams. Is it 10 grams? Yes. Then 1 mole weighs how much? How much? That equals 100 grams. Correct? 1 mole weight is nothing but gram molecular weight. 1 mole weight is always in grams is gram molecular weight. Now one more point here they have given. 1 mole, 0.1 mole of 0.05 mole of X3Y. 0.05 mole of X3Y2 weighs how much? 9 grams. So 1 mole weighs how much? It is called cumene hydroperoxide. So this will undergo a cleavage on heating, giving phenol plus acetone. This is all phenol preparation actually. But all these steps are important. Here you are getting carbocation rearrangement. Now this is called EAS, electrophilic aromatic substitution. This is electrophile. Any positive species is called electrophile. Electrophilic aromatic substitution. Now coming back to the next one. Uh, 57 direct E is equal to hc by lambda. E is equal to h nu. We know nu is equal to c by lambda. So E is equal to hc by lambda. If you apply this formula, you will get the answer. Next question. The major product C and D. The major product C and D in the following reaction. So N-propyl tertiary butyl ether. So this is the ether. CH2, CH2O, CCH3 thrice. This is the ether. Now this is treated with HI excess. See the question properly. Excess of HI and heat. So whenever the ethers are heated with HI, the first step is ethereal oxygen gets protonated. Ethereal oxygen gets protonated. So what you will get is CH3, CH2, CH2OH, CCH3 thrice, and O become positive because it donated an electron pair. This is called oxonium salt or oxonium ion. Now this oxonium ion the I minus is waiting. It will attack more stable carbocation. This bond will shift towards O. So I minus attacks more stable carbo. Phenyl is given, Br minus is given, ammonia loss that is given in the second one. But it clearly mentioned trans effect is not in the syllabus. Decreasing order of stability of O2, O2 plus, this many times we discussed. It all depends on bond order. Greater the bond order, greater the stability. You write the hint, higher the bond order, higher the stability. Option 1. 64th question. The following, which is the product form, cyclohexanone undergoes all organization. Actually, this you have to follow a very simple technique. You need not do the entire mechanism and draw all the structures. In 1 minute, you have to answer this question. So, very simple. So, cyclohexanone. Aldol condensation, 2 molecules participate. What is the final product? Alpha, beta, unsaturated ketone. Alpha, beta, unsaturated ketone. Carbonyl group, adjacent carbon is alpha, the adjacent is beta. Over, the answer is over. What is the final product in aldol condensation? Alpha, beta, unsaturated. If it is a ketone, ketone. If it is an aldehyde, alpha, beta, unsaturated, aldehyde. For example, I will give one more. What is there? So the acetaldehyde I have written. Aldol condensation. 2 moles participate. What is the product? Alpha, beta, unsaturated, aldehyde. Means the aldehyde group should be there. Adjacent carbon is alpha. The adjacent carbon is beta. So this product you will get. Over. This is alpha. This is beta. Total 4 carbons. 2 in the one molecule, 2 in other molecule. 2 molecules are condensing. So total how many carbons should be there? 4. It is called a protonaldehyde or but-2-ene-1-ol IUPAC. Suppose you want to do with CH3, COCH3, acetone. What is the product? C double bond O, you write. The adjacent carbon is alpha. The adjacent is beta, double bond. This is H. Carbons also count. How many carbons? 3, total 6 carbons should be there. So 2, 3, 4, 5, 6. 4. It is called mesitile oxide. So what is now our final understanding? In aldol condensation, the final product is alpha, beta, unsaturated aldehyde or ketone. Next. Zirconium, hafnium, lanthanide contraction, similar atomic radium we discussed. No need of this. 66. Delta H is equal to bond energies of reactants minus bond energies of products. Write that formula. Delta H for any gaseous reaction involving bond enthalpies. Delta H for any reaction involving bond enthalpies is equal to delta H for any reaction involving bond enthalpies in gaseous state. That is also must. All must be gases. Is equal to bond enthalpies of reactants minus bond enthalpies of products. Suppose if I ask you H2 plus Cl2 gives 2 HCl. Let us say this reaction I have given. All are gases. What is delta H for this? Bond enthalpy of HH plus bond enthalpy of ClCl. This is bond enthalpy of reactants minus 2 into bond enthalpy of HCl. That is the principle. So you follow the same rule and you will get the answer as the option C. You later can try. After that, assertion, reason, in SN1 reaction, chiral cell inversion is more than retention, correct? Because in SN1, a planar carbocation will be formed. A planar carbocation is formed in SN1. So nucleophile can attack from the back side or nucleophile can attack from the leaving group side. This is front attack. Or leaving group side. This is back attack. Or opposite of Lg. Opposite side of Lg. Lg means leaving group. So this causes inversion. This causes retention. So in SN1, both inversion and retention both occurs. We call racemization. But in this proportionally, inversion is more than retention. Because attacking from the same side of the leaving group is somewhat unhappy or uneasy than attacking from the opposite side. That's why inversion is more than retention. Next. This is over. Which of the following can be used as halide component in Friedel-Crafts reaction. So the options given are, one is bromobenzene, actually any halobenzene, lone pair pi conjugation. LP pi conjugation towards the benzene ring is called what? Plus M effect. Because of this plus M effect, C-Br bond gets partial double bond character. Partial double bond character. So whenever somebody gets a double bond character, what is the problem? Bond breaking becomes difficult. Bond breaking becomes difficult. So bond breaking difficult. That's why in options given, chlorobenzene, bromobenzene, chloroethene, this is called vinyl chloride. Chloroethene also, same problem, plus M effect. Plus M effect. So all these, in all these options, chlorobenzene, bromobenzene and chloroethene, there is a common effect called plus M effect. Because of this plus M effect, in all these three options, the carbon-halogen bond gets partial double bond character, and the bond cleavage or bond breaking become difficult. That's why they are not useful for Professor Firat. So Firat, I think he has not reached up to this paper. So we discuss now, but later we will put the weight on Firat. Okay? So delta TF is given, KF is given. You have to calculate I. Molality is given. What is delta TF? Minus 3.82 degrees centigrade. What is KF? 1.86 centigrade. Degrees centigrade. Mole inverse kg. No, sorry. This is what? This one. KF units. KF units, what they have given? Centigrade, mole inverse, kg. Correct? I we have to find out. For molality, weight by gram molecular weight into 1000 by weight of solvent in grams. Do Professor Firat. So, Firat, I think he has not reached up to this paper. We will discuss now, but later we will put the weight on Firat. Okay? So delta TF is given, KF is given. You have to calculate I. Molality is given. What is delta TF? Minus 3.82 degrees centigrade. What is KF? 1.86 centigrade. Degrees centigrade. Mole inverse kg. No, sorry. This is what? This one. KF units. KF units, what they have given? Centigrade, mole inverse, kg. Correct? I we have to find out. For molality, weight by gram molecular weight into 1000 by weight of solvent in grams. So weight of NEET for how many grams? 5 grams. By molecular weight of NEET4. 2 into 23 plus 32 plus 64. Please add all these. 2 into 23 plus 32 sulfur plus 4 oxygen 64. How much? Nobody is added. 142 into 1000 by weight of solvent. Weight of solvent how much? 45 grams. Now the formula is delta TF is equal to I into KF into molarity. We want I. I is equal to delta TF by KF into molarity. So this you have to substitute the values and finally you will get the answer option 1. Let us check. Next question we are going. We are not going to do the simplification. The entire thing is discussed. Later you simplify. Next question. Methyl bromide KCN. Methyl bromide KCN. You will get methyl cyanide. Now this is subjected to hydrolysis. You will get cyanides and hydrolysis become carboxylic acids. So that is again treated with lithium aluminum hydride in ether, LAH ether. LAH reduces carboxylic acids to alcohols. So this is the final product. LiAlH4, simply abbreviated as LAH. Now the sum of the coordination number and oxidation number of the metal M in the complex MEn twice C2O4Cl. Here it is bidentate. This is also bidentate. So 2 into 2, 4 dative bonds. This is 2 dative bonds. Total dative bonds are 6 dative bonds or coordinate covalent bonds. That is called coordination number. So coordination number of M is 6. Now what is the oxidation number? X plus En twice, 2 into 0, C2O4 minus 2, minus 1 for chlorine. So X is equal to plus 3. So this is X, this is 2 into 0, this is minus 2, this is minus 1. So here you will get 3, here is 6. So sum is equal to 6 plus 3, that is equal to 9. That is the answer. Next, N2O5 gas gives 2NO2 gas plus half O2. Actually, minus d N2O5 by dt is called rate of disappearance of N2O5. Why negative sign? Because reactant concentration decreases. That's why we have to put negative sign here. Is equal to whatever the coefficient here, with that we have to divide. Half into dNO2 by dt, that is equal to 1 by 1 by 2 dO2 by dt. That is equal to 2 into dO2 by dt. Now this value is given. How much? 6.25 into 10 power minus 3. Now dNO2 by dt is equal to, with this 2 we have to multiply. 2 into 6.25 into 10 power minus 3. Similarly, dO2 by dt is equal to half into 6.25 into 10 power minus 3. These are the answers. Next question. '73. Which one of the following is most reactive towards electrophilic reagent? Most reactive towards electrophilic reagent. So write a point. Greater the electron density, on the benzene ring, faster will be the electrophilic attack. Electron donating ability, electron donating ability, OH minus greater than OCH3 greater than NHCOCH3 greater than CH3 greater than CH2OH. So based on this, orthocresol, OH and CH3 side by side is called orthocresol. So this has the highest electron donating groups. So that side is the most reactive one and compared to others. Option 1 has two groups. One is OH, the other is CH. Comparatively check option B, C, D. They don't have that much powerful electron donating groups. More the electron donating groups, more the electron density on the benzene ring, faster will be the electrophilic attack. Next question. Heat and work are not state functions. They are path functions. W plus Q is nothing but internal energy. That is a state function. So both are correct. Next one. Highest oxidation state in option A N2H4, N exhibits -2. In option B ammonia -3. In option 3 N3H -1/3. In option D NH2OH -1. So among these, which is the highest value? -1/3 is highest value. All are negative values. So the less negative is more highest. That is -1/3. Next question. Which can exhibit tautomerism? This we already discussed many times, this type of persons. But anyhow, so with Actually, to exhibit tautomerism, please write a point. There should be an alpha hydrogen linked to saturated carbon or sp3 carbon. What is the condition? To exhibit tautomerism, an alpha hydrogen atom must be present on saturated carbon or sp3 carbon. Double bond O, CH3, CH3, here double bond. So this carbon is sp2, alpha carbon is sp2, so this is not fit. This is alpha carbon, but no alpha H. So only how many can possible? Which of the given compound can exhibit tautomerism? So answer 1 and 2 only, not given in your key. Key given 1, 2, 3. Why 3 cannot show? No alpha hydrogen. Carbon is linked with carbons. So 1 and 2. Make a correction. Now for the next question. Now for the reduction of silver ions with copper metal. So 2Ag plus Cu gives 2Ag plus Cu2 plus. So here it is a 2 electron change. Copper is giving 2 electrons to silver. So delta G is equal to minus NF E naught. So direct substitution minus N2 into 96,500 into E naught value, how much is that? Standard cell potential 0.46. This you have to multiply, convert into joules and all these things. You will get first option correct. 78. The oxidation of the sulfur in SO3 2 minus, that is also direct question option 1. Impact name of the compound. COH group is a terminal group. The carbon should be given number 1. So 3-cyanopropanoic acid, option 2. Now, pH of 0.01 molar strontium hydroxide. So SrOH twice. So normality is equal to molarity into number of replaceable OH groups. So normality, you have converted to normality. Molarity 0.01 into 2, that is equal to 0.02. 2 into 10 power minus 2 mole per or equivalent per liter. So POH is equal to negative logarithm of OH minus concentration to the base 10. So minus 2 into 10 power minus log 2 minus log 2 into 10 power minus 2, that is equal to 2 minus log 2. 2 minus log 2 value 0.3010, well known value. So 1.6990. This is POH. You know pH plus POH is equal to 14. So pH is equal to 14 minus POH. So 14 minus 1.6990. So that gives the answer. So this is the strontium hydroxide. Next question, 81. Faster with H2 under catalytic hydrogenation. Write a point. More substituted alkenes are more stable and give less heat of hydrogenation. Double bond low. CH3, CH3, here double bond. So this carbon is sp2, alpha carbon is sp2, so this is not fit. This is alpha carbon, but no alpha H. So only how many can possible? Which of the given compound can exhibit tautomers? So answer 1 and 2 only, not given in your key. Key given 1, 2, 3. Why 3 cannot show? No alpha hydrogen. Carbon is linked with carbons. So 1 and 2. Make a correction. Now for the next question. Now for the reduction of silver ions with copper metal. So 2Ag plus Cu gives 2Ag plus Cu2 plus.